Using a plug tester in a 120 volt 15 or 20 amp receptacle that is wired for 220 volts can be dangerous and can result in several negative outcomes. Firstly, electrical shock and injury is a risk. The higher voltage of 220 volts can cause a severe electrical shock, potentially resulting in burns, cardiac arrest, or even death. The metal prongs of the plug tester can become energized, posing an electrocution hazard if touched. Secondly, equipment damage can occur. The plug tester is not designed to handle 220 volts and may be damaged or destroyed. Furthermore, any appliances or devices plugged into the incorrectly wired receptacle may also be damaged if they are not rated for 220 volts. Thirdly, there is a fire hazard. The excessive current flow through the plug tester or connected devices, due to the voltage mismatch, can generate heat and potentially start a fire. Fourthly, electrical malfunction is a possibility. Using a plug tester in a receptacle with incorrect wiring can cause electrical malfunctions within the circuit, such as the breaker tripping or damage to the wiring itself. If you suspect that a receptacle is wired incorrectly, it is crucial to take the following steps to ensure safety. 1. Unplug all devices. Immediately disconnect any appliances or devices from the receptacle to prevent further damage or hazard. 2. Turn off the breaker. Locate the circuit breaker that controls the receptacle in question and turn it off to de-energize the circuit. 3. Use a voltage meter. Verify the voltage of the receptacle using a voltmeter or multimeter to confirm the suspected incorrect wiring. 4. Contact a qualified electrician. If the receptacle is indeed wired incorrectly, it is essential to contact a licensed electrician to correct the wiring and ensure electrical safety. Never attempt to fix electrical wiring if you do not have the necessary training and experience. Electrical work should always be performed by a qualified electrician to prevent injury and property damage. Always consult a qualified electrician for electrical work. An electrician will follow best practices to safely diagnose and repair the problem. Before starting any work, the electrician will ensure the power is off to the circuit by using a voltage tester to confirm that the circuit is energized. They will also identify the source of the incorrect wiring, which could be a mistake made during the initial installation or a modification done later on. The electrician will trace the wiring back to the electrical panel to ensure that the circuit is properly connected and labeled. If the wiring is incorrect, the electrician will correct it by properly connecting the wires according to the electrical code. This may involve rerouting the wires or replacing the receptacle with the correct type. The electrician will also ensure that all connections are tight and secure to prevent loose connections, which can cause electrical problems. After correcting the wiring, the electrician will test the receptacle to ensure that it is working properly. They will use a voltage tester to verify that the voltage is correct and that the polarity is correct. They will also use an ammeter to check the current flow to ensure that it is within the safe limits for the circuit. Finally, the electrician will label the receptacle to indicate that it has been inspected and approved for use. This will help to prevent future problems and ensure that the receptacle is safe for use. Some common causes of miswired receptacles include incorrect wiring during installation, damage to the wiring, and modifications made to the electrical system. Incorrect wiring during installation can occur if the electrician is not properly trained or if they make a mistake while connecting the wires. Damage to the wiring can occur if the wires are exposed to moisture, heat, or physical damage. Modifications made to the electrical system can also cause miswired receptacles if the modifications are not done properly. There are several different types of receptacles that are commonly used in homes and businesses. The most common type of receptacle is the 120 volt 15 amp receptacle. This type of receptacle is used for general purpose applications such as lighting, appliances, and electronics. Another common type of receptacle is the 120 volt 20 amp receptacle. This type of receptacle is used for appliances that draw more power, such as refrigerators, washing machines, and dryers. There are also 240 volt receptacles which are used for appliances that require a higher voltage, such as electric ranges, ovens, and water heaters. The National Electrical Code, or NEC, provides guidelines for the safe installation and use of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to follow the NEC guidelines when installing or modifying electrical systems to ensure safety. When working with electrical systems, it is important to use the proper tools and equipment. Some essential tools for electrical work include a voltage tester, an amp meter, a wire stripper, a screwdriver, and pliers. It is also important to wear personal protective equipment such as safety glasses, gloves, and a hard hat. Before starting any electrical work, it is important to identify the circuit that you will be working on. This can be done by using a circuit breaker finder or by tracing the wires back to the electrical panel. Once you have identified the circuit, you should turn off the breaker to energize the circuit. It is important to verify that the circuit is energized by using a voltage tester before starting any work. When connecting wires, it is important to use the correct wiring methods. The NEC specifies the types of wiring methods that are allowed for different applications. It is important to follow the NEC guidelines when connecting wires to ensure that the connections are safe and reliable. When installing receptacles, it is important to follow the manufacturer's instructions. The manufacturer's instructions will provide information on the proper installation methods and the torque specifications for the terminals. It is important to use the correct torque specifications to ensure that the connections are tight and secure. When testing receptacles, it is important to use a voltage tester to verify that the voltage is correct and that the polarity is correct. The voltage should be within the range specified by the NEC, which is typically 110 volts to 125 volts for 120 volt receptacles. The polarity should be correct, with the hot wire connected to the black wire and the neutral wire connected to the white wire. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. A qualified electrician will have the training and experience to safely and properly install or modify electrical systems. Hiring a qualified electrician can help to prevent electrical problems and ensure the safety of your home or business. Regular electrical inspections can help to identify potential problems before they become serious. Electrical inspections should be performed by a qualified electrician and should include a thorough examination of the electrical system, including the wiring, receptacles, and electrical panel. If any problems are found during the inspection, they should be corrected immediately to prevent electrical hazards. If you are planning to make any changes to your electrical system, it is important to obtain the necessary permits. Electrical permits are required for most electrical work, including new installations, modifications, and repairs. Obtaining the necessary permits will ensure that the work is done safely and in compliance with the electrical code. It is important to be aware of the potential hazards of electricity and to take precautions to prevent electrical accidents. Some common electrical hazards include electrical shock, electrical fires, and arc flash. To prevent electrical accidents, it is important to follow the NEC guidelines and to use the proper tools and equipment when working with electrical systems. It is also important to be aware of the location of electrical hazards, such as overhead power lines and underground cables. If you come into contact with an electrical hazard, it is important to stay away from the hazard and to call for help immediately. Electricity can be a dangerous force, but it can also be a valuable resource. By following the NEC guidelines and taking precautions to prevent electrical accidents, you can safely enjoy the benefits of electricity. When dealing with electrical outlets, it's also worth noting that ground fault circuit interrupters, or GFCIs, are essential safety devices. GFCIs are designed to protect people from electrical shock by monitoring the current flowing through a circuit. If a GFCI detects a leakage of current, indicating a ground fault, it will quickly trip the circuit, cutting off the power and preventing a potentially dangerous electrical shock. GFCIs are typically required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. It's important to test GFCIs regularly to ensure that they are functioning properly. To test a GFCI, simply press the test button on the device. If the GFCI trips, it is working correctly. If it does not trip, it should be replaced immediately. Arc fault circuit interrupters, or FSIs, are another type of safety device that is becoming increasingly common in homes and businesses. FSIs are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can occur when wires are damaged or loose. When an FSI detects an arc fault, it will quickly trip the circuit, cutting off the power and preventing a potential fire. FSIs are typically required in bedrooms and other areas where people sleep, as these are the areas where electrical fires are most likely to occur. It's important to test FSIs regularly to ensure that they are functioning properly. To test an FSI, simply press the test button on the device. If the FSI trips, it is working correctly. If it does not trip, it should be replaced immediately. Understanding the basics of electrical circuits can also help to prevent electrical problems. An electrical circuit is a closed loop that allows electricity to flow from a power source to a load and back again. The power source provides the electrical energy, the load consumes the electrical energy, and the wires provide the path for the electricity to flow. The three main components of an electrical circuit are voltage, current, and resistance. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of electrical current in a circuit. It is measured in ohms. Ohm's law is a fundamental law of electrical circuits that states that the voltage across a resistor is equal to the current through the resistor times the resistance of the resistor. Ohm's law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. When working with electrical circuits, it's also important to understand the difference between series circuits and parallel circuits. In a series circuit, the components are connected in a single path, so the current flows through each component in turn. In a parallel circuit, the components are connected in multiple paths, so the current can flow through each component independently. The total resistance of a series circuit is equal to the sum of the individual resistances. The total resistance of a parallel circuit is less than the smallest individual resistance. Understanding these basic concepts can help you to troubleshoot electrical problems and to make sure that your electrical system is safe and reliable. Always consult a qualified electrician for any electrical work that you are not comfortable doing yourself.